we are going to be doing today is to determine the refractive index of a glass block. Precisely, we are making use of a rectangular glass block. The apparatus we are going to be using for this very experiment, we are going to be making use of a glass block. Then we have our optical pins right here. Then we need a board too. We have our board here and some plain sheet of paper to do our tracing. Here with me are my 4 students, and we're about to go ahead with the practicals. Now, quickly because of our time, the first thing we need to do, we need a plain sheet of paper, which we have here, and I'll need to distribute that to my students so that they can have their own papers too. Alright, so we have our plain sheets of paper, and then we need an optical pin. Precisely to do our tracing here, I think we are going to need 3 optical pins to carry out this experiment successfully. I think the same thing to those students. I think it can help themselves out here. Now, what we need to do here is to make a trace of the glass block. So I'll need to place it on my plain sheet of paper and then make a trace. I think you have to come closer now so that you can see what I'm doing. You need to make a trace. Alright, so now that we've made a trace of the glass block we have there, the next thing we need to do, we have to make a normal on this particular trace, and we measure an angle of incidence. Our first angle of incidence is going to be 15 degrees, and then we'll take 4 other measurements as we proceed with the practical. So for us to take our normal, a normal is a straight line on our trace. So let's make a normal. We have to use broken lines now. Now the first thing we need to do, we need to measure our angle 15 degrees, and we need to do that with our protractor. So we need to place that here and measure 15. Now looking at the calibration, you make sure that this inner part tallies with your line, and then we can go with the 15 degrees. So you are going to read from inside, not outside. We are reading from inside this time around. So we have, this is, each of them is 5, so this is 10. So the middle here should be 15. Yeah. So we have 15 degree there. Mm-hmm. So we have our 15 degree. You can use this rule just to join that together. Now that is our 15 degrees. Now the next thing we have to do here is to spot 2 pins. The reason why we are using 2 pins is because we want to get a perfect trace. Because we believe that 2 points should give you a straight line. So already we have a straight line, but for us to get our proper trace from the other side when we are viewing, we need to use 2 pins. So we place the 2 pins on the straight line. It has to be exactly on the line. I think we have to put that properly. Alright, so we have that. Now the next thing we have to do, we bring back our glass block. We have to place it on the trace. Then right there we have our trace there. Everything is intact. Okay, now the next thing we have to do is to move to the other side to view. We are going to view and place our pin. Where's the remaining optical pins? I really want to know. This one is somehow there. Okay, don't worry. I'll move this one. So we need to view from the other side and check where it tallies with these two pins. Where they tally and form a straight line. That is where we are going to fix our pin. So you have to do that. This part is quite sensitive, so you just need to position your eyes properly so that you get the perfect. Alright. So right there on the straight line. Where the two pins are on the straight line.